first section we're doing is stem and leaf plots. The stem is the greatest place values of the data. The leaves are the least place values. So everyone needs to write this down. So we're going to use a stem and leaf plot to show the bowling scores. Right? Stem and leaf plot, right, and box and whisker, which we're going to talk about, is just another way of organizing the data. It gives you a better look at the data. Right now, okay, it's just a bunch of numbers. Up here is just a bunch of numbers. You can't really tell the mode or the median just by looking at it. And you can write them down in order, but it's still, this saves space, right? And it just gives you a better way of organizing it, looking at what the numbers are doing. So this part is the stem, and it's the greatest place values. This is your leaves, and that's the least place value, the smallest. So what I do is I start with my smallest number, which is 122, and my stem is going to be 12. And my leaf is going to be a 2. Okay? So right here I have 122. But also on that stem of 120, I also have 128. I also have 129, so I put a 9 on the leaf. I don't need to rewrite 123 times. I write it one time, and then I have different leaves that break off of that stem. And then I'm done with the 12 for the stem, so then I'm going to go to my next one, which is 13. And the only leaf I have on that one is a 5. What would be my next stem? 14. What would be on it? 4. Good. My next stem would be 15. I have a 7. I have an 8. I also have another 8. Okay, every time it occurs, you write it. I have 160. Okay, 0 would be my stem. Then I have 177. And the only thing left is 199, right? Okay, so this is a stem and leaf plot. This looks a whole lot better than this. I also saved a lot of space. All right? If I was to write out every one of these numbers, I would take up a whole lot more space than this. So this is a way of organizing it. Now, I also have to give a key. Anytime you make something, you give a key. So what I do is I just do this, and I just do one of the numbers. Okay? So I write down 12, and then a line, and then 2, and I said that's equal to what? 122. So someone that's never seen a stem and leaf plot before can figure out that 12/2 is 122. Or 12/8 is 128. Okay, so you always give a key when you make a stem and leaf plot. Now, let's think about this. Does this help me to figure out my mode? Yeah. Okay, just looking at these numbers up here, okay, you have to do a lot of comparing and looking to see. Here, what's my mode? 158. Okay, it is obvious. It's the only one where the leaf's the same. What about the median? Doesn't it make the median easier to find? Okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers. So 1, 2, 3, 4, 5, 6. There's my median, 157. If you need to check, you can count backwards. 1, 2, 3, 4, 5, 6. Easy, right?
So do you just round up to the next number up instead of doing halves?
For what? No. If there's an odd number, which there's an odd number of numbers here, okay, then the middle number, which would be 6, okay, if there's 11, the middle number will be 6, so it's 157, right? Yeah. If there's an even number, let's say, like we didn't have this 2, so there's only 10 numbers, then what we do is we find the average of the middle two numbers, which would be 7 and 8. What's the average of 157 and 158? 157 and a half, right? Okay. Does everybody understand? Easy enough. All right, write this down. All right, this just tells you what a box and whisker plot is. Okay, and I'm going to show you here in a minute, and I'm going to show you how to find it. It's just a data display that divides a set of data into 4 parts. So each section of a box and whisker plot is 25% of the data. All right, everybody understand? So what you need to do is write this down. This is the description of the quartiles, which is the 3 dividers in a box and whisker plot. Alright, so the reason I put second quartile first is because that's the first section you want to find. It's the median of the numbers, of all the numbers, so you find the middle number, okay, and that splits it in half. Now you've got 2 sections, the top half and the bottom half, each 50% of the data. The first quartile is the median of the smaller half of the numbers. So your lower extreme, which is going to be your first number, to the second quartile, the first quartile is right in the middle. That would split the lower half into 25%. So each section is now a quarter of the data. And then your third quartile is the median of the larger half numbers. So you take the middle half of the numbers, you split them in half. So now you've got 4 parts to the data. And you can kind of see where it's distributed. Right? Where's the most of the data? What's occurring most? All right, so that's the parts of a box and whisker plot that you need to know. Here's another part. You need to know the lower extreme and the upper extreme. So write this down. The lower extreme is the smallest number. That's your starting point. The upper extreme is your highest number. That's your ending point. Those are going to be the ends of the whiskers of the box and whisker plot. All right, so before you actually do a box and whisker plot, what you got to do is you got to use the data to make one. You've got to distribute the data up and organize it into 4 parts. So what you do first is you classify your lower extreme and you designate your upper extreme, which would be 47. And then the first thing you do after that is you find the median of all the numbers. You find your second quartile, because that's the middle. So I find the middle of these 2 numbers, of all these numbers, the middle would be between these 2, right? Here I've got 4, here I've got 4. So I find the median of these 2 if I find the average of 29 and 32, which does anyone know what that'd be? 30.5, good. 30.5 is my second quartile. Then I find my first quartile, and it's the middle of the lower numbers. So what would be the middle of these numbers? 26. Okay, it'd actually be. I mean, it would be. No, because it would be 26 and 26, right? So what's the average of 26 and 26? 26, right? So this is my first quartile. And then I find my third quartile, which is the median of the top half, the bigger numbers. So what will be the median there?
31.5.
Well, if this is your first number and that's your last number, what would be the middle of those? 1, 2, 1, 2, 39, right? So this is my third quartile. So now I've got it labeled. Now I can make a box and whisker plot. So first thing I do is I draw a number line. So go ahead and draw this number line. After you've drawn the number line, you need to label your upper extreme and your lower extreme. What was the lower extreme? 25, right? This is my lower extreme. So I put a dot at 25. What's my upper extreme? What'd you write down? 47. So I need to put a dot about 47. This is my upper extreme. Then I label my second quartile. Okay, I like to do it in the order that we found it. What's my second quartile? What would we say that was? 30.5. So right there. What was my first quartile? 26. I just put the dots. I'll show you why here in a second. Okay, and what's my third quartile? 39. And then what I do is I make my box and whisker plot. Now the box, okay, is the middle is your second quartile, and the ends are your first and third quartile. So I make a box just like that. And then my whiskers go from the third quartile to the upper extreme and my first quartile to my lower extreme. And there I have a box and whisker plot. Now remember, each section is 25% of data. So what does this tell me? What can you see? Okay, the upper extreme, there's more of a difference. Okay, but if you look, the lower part of this is more concentrated. 50% of data goes from 25 to 30.5. A 5.5 difference, right? 5.5 range. What about the middle to the upper extreme? Goes from 30 to 47. A 17 difference, right? A range of 17. See how so half of the data is really concentrated. Right in the middle. Right there. And then the upper half is spread out. Does that make sense? Alright, so let's do another one. Write down these numbers. Alright, so after you write down the numbers in order, okay, here is your lower extreme. Here's your upper extreme. So then what we do is we find the middle. We find the median. We find the second quartile. What would be the second quartile? It's going to be the median of 82 and 85, right? 2, 3, 4, 5, 6, 7. So what's the median of 82 and 85? What's the average of 82 and 85? 83.5. Good. That's your second quartile. Your middle number. Then we find the first quartile, the middle of the lower half, or the top of the smaller numbers. 1, 2, 3, 4, 5, 6, 7, 8. So my average would be 1, 2, 3, 4. Okay, my median is going to be between 72 and 81. What would that be? 76.5. So that's my first quartile. And what would be my third quartile, my middle number of the top half? 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1, 2, 3, 4. What's the average of 95 and 98? 96.5. There we go. That's your third quartile. Okay. Now that you've figured it out, you figured out the parts of the box and whisker plot, then you can put it on a number line. So let's do that. Okay, so draw the number line. All right, now the book a lot of times draws the box and whisker plot above the number line, so we're going to do that as well. What was our lower extreme? What was our smallest number? 51. So I'm going to put a dot above 51. What was my upper extreme? Largest number. So just in front of 105. So that's going to be the end of the whiskers. What's my median? What's my second quartile? That's the one I like to find first. 83.5, so that needs to go about there. What about my first quartile? 76.5. Now, what about my third quartile? All right. Okay, so I put the box around the first and third quartile. The second quartile just gets a line down the middle, and then I add my whiskers. And you can draw a line through the middle if you want. So what does this tell me about the data?
The lower extreme is...
Okay, well, the first, now remember, this is 25% of data, this is 25%, this is 25%, this is 25%. Where's it most concentrated? Where is most of the number? Okay, well, you've got 25% of data is here between 76 and 81, right? So if you said you had a total of 10 numbers, right, three of those numbers would be right there. And then 3 of these numbers would be really stretched out. See how this is far? Okay, so 25% of data is pretty stretched out. Here it's concentrated. Here it's not as much, kind of stretched out. And then here, between your third quartile and your upper extreme, 25% of data is kind of close together again. So you can kind of see where most of the numbers are. Okay, and they're right in there. That's the smallest part. Okay, any questions? All right, here's your assignment. It'll be due tomorrow.